Everyone tells you to buy more GPUs to make your local AI faster. And technically, with most of these tools, a second GPU won't speed up a single response. But that's not the whole story. And the real answer depends entirely on which software you picked. Because these 5 tools handle multiple GPUs in completely different ways, and the ones you choose decides whether the second GPU gives you more speed, more room, or just a higher electricity bill. This is going to be honest breakdown, but before we get into that, my name is Daniel Jindil, and I used to run AI info business that questions my moral every single day, and eventually I had to quit. Now I'm just giving away everything I know about AI for completely free. No gatekeeping, you can join my community for free, newsletter to get as much value as possible. You can take it all. All I'm asking for is maybe consider dropping comments on this video to help me keep going, but up to you, not necessary. One of the comments on the latest video were loud and clear. You wanted the real comparison, not the sponsorship kind, not the I used it for 5 minutes kind, the kind where someone actually digs into how these things work. So here it is, 5 tools, same job. Running AI on your own machine. They look very similar on the surface, but underneath, completely different animals, and the one you pick decides everything else. Let me introduce the 5. Think of each one like hiring a different type of worker for the job. Number 1, Ollama. This is the handyman. Shows up fast, gets it running in 10 minutes. You type one command in your terminal, your AI model downloads and starts. Done, that's it. It runs quietly in the background on your computer unless other apps connects to it. If you want a local AI up and running with the least amount of work, this is usually the first answer. Number 2, LM Studio. This is the interior designer. Beautiful app you download on your computer. You browse AI models, click downloads, start chatting, no typing commands. If you're on a Mac or you just want the friendliest experience possible ever, this is your choice. This is it. Number 3, llama.cpp. This is the general contractor, the real foundation that a lot of these other tools are actually built on top of. It's written in a way that makes it run on basically anything, laptops, servers, your phone, or even the weird hardware that you've never heard of, that nobody else supports. You get the most control, but you're doing more of the setups yourself. Number 4, vLLM. This is the architect. Multiple users at once, multiple GPUs. If you need to serve an AI model to a team of maybe 50 different people at the same time, this is the only real options on the list. But it needs serious equipment to match. This is not a casual tool. Number 5, KoboldCpp. I've actually never used this, so I had to kind of play it around for a day. But this is the tinkerer with every tool in the garage, built on top of llama.cpp, but it has a full visual interface in your browser. Image generation, even text-to-speech. You download one file, double-click it, and it runs. It's the hobbyist playground. So at the surface level, you pick based on what you need. Easy background engine, you can go with Ollama. You want pretty desktop app, you can go with LM Studio. You want full control, llama.cpp. If you want serious multi-user server, vLLM. If you want creative background, KoboldCpp. It's very simple, right? That's the surface level, and here's where most people get burned. Because the tool you pick does not just change how the app looks or feels, it changes what hardware you actually need. And this next part, I guarantee most people watching this have never heard explained properly, unless you know what you're doing. Listen carefully, here's the thing nobody tells you about using more than one GPU. There are 2 completely different ways these tools spread an AI model across multiple GPUs, and they produce completely different results. Way number 1, the relay race. The technical name is pipeline parallelism, but think of it like this. An AI model is made up of layers. Think of layers like floors in a building. When your AI thinks, it has to go through every single floor one at a time from bottom to the top. With this method, I'm going to call GPU 1 and GPU 2. Okay, so GPU 1 handles the bottom floors, GPU 2 handles the top floors. GPU 1 does its work, passes the results up to GPU 2, and while GPU 2 is working, GPU 1 is just sitting there idle, waiting. This is what Ollama uses, LM Studio uses, KoboldCpp uses, llama.cpp uses by default. So what does that actually mean for you? If you buy 2 GPUs and load a big model across both of them this way, a single response does not come back any faster. One GPU is always waiting while the other one works. There is no speed increase for any single question that you ask. Here's the important part that most people miss out. If that AI model was just too big for one GPU, like 70 billion parameters models, or even more, much more, part of it was running on your regular computer memory, which is way slower than GPU memory. Think of it like the difference between running on a paved road versus running through a mud. By adding a second GPU, you moved everything onto the fast road. So yeah, more GPUs can absolutely make things faster, of course, just not because of the splitting part. It's the actual stopping the slower path. Way number 2, the team lift. The technical name is tensor parallelism. Instead of splitting the model into floors, this method splits the actual math. Every GPU works on a piece of the same problem at the same time, all of them all together, but this actually makes each response faster, real speed increase. More GPUs, now actually more speed, but there's a catch. Because every GPU needs to share its work with the others after every single step, they need to talk to each other constantly. And that talking needs to happen really fast. That being said, you need special high-speed connection between your GPUs. We call that NVLink bridges. Think of NVLink like a private highway between your GPUs. Obviously without it, the GPUs are just stuck talking through the regular connections, which is like a 2-lane road, too slow. There's no speed advantage. It just completely disappears. Regular connections between GPUs are fine for the relay race methods, of course, but the team lift methods needs that private highway. And that highway can cost hundreds and even thousands of dollars if you're looking at like going beyond the consumer setup. So the software you choose literally decides whether you need a regular connection or an expensive high-speed bridge. Same GPUs, different software, different hardware budget. Now here's the part that I found about it recently. llama.cpp can use something called Vulkan. Vulkan is a way of talking to GPUs that works across different brands. And because of that, llama.cpp is the only tool on the list that can combine an NVIDIA card and an AMD card in the same machine, running one model altogether. Every other option needs your GPU to be the same model. llama.cpp just doesn't care. Mix and match is possible. And recently, llama.cpp added a new mode called row split. This gives it its own version of the team lift method. So now you can get actual speed improvements across multiple GPUs in llama.cpp, not just more room. It's still limited by how fast your GPUs can talk to each other, but the fact that it exists is a big deal for people who don't want to run a full production server setup, like myself. Okay, so let's break this down. The relay race gives you more room to fit bigger models, doesn't speed up single responses, works with regular connections. The team lift, on the other hand, actually speed things up, but you have to pay for expensive high-speed connections between your GPUs. Your software choice makes that decision for you. But you have to understand that some older graphics card models, they do not support NVLink. Like 3060, 3070, 8090, they do not support NVLink, so you have to keep that in mind, okay? So the hardware story goes way deeper than just buy a GPU, but here's the part that should actually concern you, because none of these tools are as safe as you think you are. So I want to be clear about this. Every single tool on this list has a security hole, obviously, that can bite you if you don't know about it. Why don't we start with Ollama? By default, it only talks to your own computer. Nobody else on your network can reach it. Good. But the moment you want to use it from another device, like your laptop talking to your server in the other room, you flip one setting, and suddenly your AI server is just wide open to every device on your local network. No password, no log, nothing at all. And here's the wild part. Ollama has a spot where you can put in a password called an API key, but their own documentation says it's required, but ignore. Those are their words, but the password field exists so other tools do not break. It doesn't actually protect anything. People have their Ollama servers found and used by strangers. Someone on the internet running AI on your machine, using your electricity without your freaking permission. And it gets even worse. Ollama had a security flaw called problema that let an attacker completely take over your computer, not just using your AI, taking over your entire machine. That was fixed fortunately, but only if you actually install the update. KoboldCpp, so I dug a little deeper about this, and depending on your version, it can be visible to every device on your network by default, not just your computer, and this default setting can even let random websites you visit in your browser connect to your local AI. Think about that for a second. Isn't that scary? vLLM, it has a password option, of course, but it only protects the main door. Other doors into the system stay wide open unless you block them yourself with separate security tools. And vLLM has its own critical flaw, rated 9.8 out of 10 on the severity scale, which is nearly the worst possible. Someone could send a specially crafted video link and take over your entire system right at the spot. LM Studio is actually one of the better ones out there, and that's probably why so many experts on YouTube are using it right now. It has a switch to require a password for connections, but that switch is off by default, and because nobody else at the company can look at the actual code, security researchers cannot really check what's really happening inside. So I guess that kind of gives you a peace of mind, right? llama.cpp gives you the most control here. It supports password, it supports encrypted connections. You can lock it down properly if you know what you're doing, but you have to set all of that yourself. Fresh out of the box, it's just as open as everything else. So what do you actually do? 3 rules here. 1. Keep your AI server locked to your own computer only. Don't open it to your network unless you have a real reason for it. 2. If you do need to access it from other device, put a security guard in front of it. There are free tools like NGINX or Caddy, which I use, that sit between your AI server and the network, and they check password before letting anyone through. 3. Keep your software updated, please. These security flaws get fixed, of course, but only if you actually download the fix. And this applies to every tool that you use, whether that is an OpenClaw or Codex or Cloud Code. Update your tools. All right, last piece of the puzzle. What happens when more than one person or more than one app tries to use your local AI at the same time? This is where the differences become massive. Ollama handles one question at a time by default. You can change a setting to handle more, but it gets messy fast, I think. First person gets a quick answer, second person waits, third person waits longer. It's fine when it's just you, but falls apart when there's more than one person. LM Studio recently added the ability to handle a few people at once. It helps, but it's still a desktop app doing server work on the side. Now the llama.cpp is better. You can set it up so 4 people use it at the same time simultaneously, but it divides thinking space equally. 4 people, each person gets a quarter of the memory. That means shorter conversations for everyone. Not really ideal for a complex back and forth, right? And then there's vLLM. This is where it gets genuinely impressive. vLLM uses a technique called PagedAttention, and it's based on how your computer is already managing your own memory. I think the simplest way to think about this, imagine a parking lot. Most AI tools reserve an entire section of the lot for every car that might show up, right? Even if only a few cars actually come, most of the lot sits empty, which is a wasted freaking space. PagedAttention, on the other hand, works more like a parking garage. Cars pull in and slot into whatever space is open. No reserve section, no wasted space, wasted room. The research shows that this approach wasted 60 to 80% less memory than the traditional way. On top of that, vLLM does not make people wait in line. The moment one person answers is done, the next person's question slides in immediately. There's no gap. One test showed Ollama handling about 41 words per second, while vLLM handled 793 in the same setup. Same hardware, same model. Isn't that crazy? Because that is not a small difference, that's a whole different universe. It's like, phew. So the decision is very simple. If it's just you working, Ollama or LM Studio will do the job. But if you want control, go with the llama.cpp. If you want actual real production use, multiple users, serious speed, you gotta go with the vLLM. Period. Well, if you have a Mac with Apple Silicon, LM Studio or Ollama. Macs, as you know, they share their memory between the processor and the GPU. We call it a unified memory, right? Which means a high-end Mac Studio with 192 gigs of memory can run AI models that would need 4 to 8 server-grade GPUs on a regular PC, and that is real. That's how the hardware works, and that's the world works. Monopoly, but I love it. Single GPU, you like typing commands, you can go with the Ollama, and single GPU, you like clicking buttons, go with the LM Studio. Multiple GPUs and you want to fit bigger models, llama.cpp. It gives you direct control over which GPU handles which part of the model. Multiple GPUs and you want actual speed, vLLM is the way. All your GPUs work on the same problem at once, but plan for the high-speed connections between them. I mean, what other software can you think of? You have different GPU brands, like one NVIDIA and one AMD, and the same machine, llama.cpp. It's the only tool that supports this, unless I'm missing out on something, let me know. And if security is your top priority, llama.cpp gives you the best built-in password and encryption option. Or put vLLM behind the security layer that I talked to you about if you need something production grade, NGINX or Caddy, right? If you want creative writing, storytelling, tinkering, KoboldCpp, that's literally what it was built for, I think. I don't think it's really useful, but it was fun. Here's what I want you to take away from this. The software you pick to run AI model locally decides everything else. Your hardware budget, whether your second GPU actually does anything useful, whether your server is locked down or wide freaking open, whether you can serve one person or 100. There's no single best tool. There's only the right tool for what you're actually trying to do. And now you know enough to pick the right one. If your company is trying to implement a local AI model in full in-house, then you gotta go with the what? vLLM, because it supports multi-users better than anything else. So I put together a free PDF comparison chart, a security checklist, and hardware recommendation by budget, link in the description. If this saved you from buying the wrong hardware or leaving your server exposed, drop a comment and tell me which tool that you're going with, because I read every single comment. See you in the next video.